Democritus, a Greek philosopher, was the first to propose that matter is comprised of fundamental indivisible particles, which he called atomos, meaning uncuttable. Democritus believed that atoms were constantly in motion, colliding and combining to form different substances. However, his theory was not widely accepted during his lifetime. It laid the groundwork for future scientific investigations, ultimately led to the development of modern atomic theory. Now let's move on to John Dalton's atomic theory. John Dalton is a British scientist. His theory was based on experimental observations and built upon the ideas of earlier thinkers like Democritus. There are 5 key points about the John Dalton's atomic theory. The first one is indivisible atoms. This idea was similar to Democritus' theory, but Dalton's theory was based on more concrete evidence. The second one is identical atoms. Atoms of the same elements are identical in size, mass, and chemical properties. The third one is different atoms, meaning atoms of different elements are different in size, mass, and chemical properties. The fourth one is whole number ratios. Chemical compounds are formed when atoms of different elements combine in whole number ratios. And the last one is conservation of mass. That means atoms cannot be created or destroyed in chemical reaction. Dalton's theory provided a framework for explaining the properties of elements and compounds and laid the foundation of modern chemistry.
J. Thomson was a brilliant British physicist who made significant contribution to our understanding of atoms. Thomson proposed a model of the atom that he called the plum pudding model. Imagine a sphere of positive charge, like a pudding, with tiny, negatively charged electrons embedded within it, like plums. This model suggested that the atom was a neutral entity with positive and negative charge evenly distributed.
Ernest Rutherford. Ernest Rutherford was a brilliant New Zealand-born physicist who made significant contributions to the field of nuclear physics. Rutherford's experiment involved bombarding a tin gold foil with alpha particles. Alpha particles are positively charged particles emitted by radioactive materials. The idea was to see how the alpha particles would interact the atoms in the gold foil.
Niels Bohr. Niels Bohr was a brilliant physicist who made significant contributions to our understanding of quantum mechanics. Bohr proposed a model of the atom that suggested electrons orbit the nucleus in specific energy levels of shells. These shells were numbered from 1 to 7, with the innermost shell being the first, and it's called Bohr's orbit model. Louis de Broglie and Erwin Schrödinger were 2 influential physicists who played crucial roles in developing the quantum mechanical model of the atom. The wave mechanical model of the atom, developed by Louis de Broglie and Erwin Schrödinger, is a fundamental pillar of modern quantum mechanics. It represents a significant departure from classical physics, which views particles as having definite positions and velocities. Together, their contributions laid the groundwork for a new understanding of the universe at the atomic and subatomic levels, paving the way for groundbreaking advancements in fields such as quantum computing, material science, and nanotechnology.